Hi, I'm Andy and this is question 8 on the AQA Decision 1 paper from January 2008. For more questions on this exam paper, click the eye in the top right corner. In question 8, we're told each day a factory makes 3 types of hinges: basic, standard and luxury. The hinges produced need 3 different components, type A, B and C. And then we've got various information about the constraints on the amount of each type of hinge and component that we have available. And the question is asking us to find 5 inequalities in addition to x is greater than 0, y is greater than 0, z is greater than 0, each involving x, y and z, which must be satisfied. And we need to simplify each inequality where possible. So first of all, I'm going to find 3 inequalities using the information it tells me about how to make basic, standard and luxury hinges. But before I start, the first thing I need to do is look through and say, what do my decision variables represent? And that's on this line at the bottom here, which says each day the factory makes X basic hinges, Y standard hinges and Z luxury hinges. So for the decision variables, be careful with the language you use. X doesn't represent basic hinges, it represents the number of basic hinges that you manufacture. The same with Y. Y is the number of standard hinges and Z is the number of luxury hinges. The first constraint I'm going to put together is going to involve components of type A. So I know from the bottom here that there are 360 components of type A available, and I'm going to write an expression which represents the number of type A components that I've used. So let's imagine I'm making some basic hinges. I need 2 components of type A. And if I made X of those components, I would need 2X components, 2 times the number of basic hinges I make. Then if I think about the standard hinges, there are 4 components of type A for that. So I would need 4 lots of Y. That would tell me how many type A components I need to make all of the standard hinges I'm going to make. And for the luxury hinges, I need 3 components of type A to make each one. So in total, that would be 3 multiplied by Z, which is the number of luxury hinges. So this expression represents the total number of type A components, and I know that has to be less than or equal to 360. Always check when you're doing these if you can divide through. There's nothing that goes into 2, 3 and 4, so that stays as it is. Next we'll do type B. So for the basic hinges, I need 3 components of type B, so that would be 3X. For the standard hinges, I need 2 components of type B to make each one, so that would be plus 2Y. And then for the luxury hinges, I need 4 components of type B, so that would be plus 4Z. So this expression here represents the total number of type B components that I'm going to use. And it tells me on the bottom line here that I have 270 of these available. So that must be less than or equal to 270. Finally, for type C, to make all of the basic hinges, I need 1 component of type C for each, so that would just be X. I need 3 components of type C to make the standard hinges, so that's plus 3Y. And I need 5 components of type C to make the luxury hinges, so plus 5Z. And I have 450 available in total, so that must be less than or equal to 450. So these are my first 3 inequalities. To get my next 2 inequalities, I need the extra statements that are given here. We're told that each day the factory must use at least 720 components in total. Well, look at our expressions here. This expression represents the total number of type A components, this expression represents the total number of type B components, and this expression represents the total number of type C components. So we're going to write a constraint for the total number of components. So the total number of components will be all of these added together. So we've got 6 lots of X, we have got 4, 5, 6, 7, 9 lots of Y, and 5, 9, 12 lots of Z. This represents the total number of components here, and that must be greater than or equal to 720 because I must use at least 720 components. Now this inequality will simplify because 3 goes into everything, so dividing by 3 gives me 2x plus 3y plus 4z is greater than or equal to 240. And the final constraint says that each day the factory must use at least 40% of the total components of type A. Well, fortunately, I've already found an expression that represents the total number of components. That's this expression here. Be careful not to use your simplified version, because this expression here, the 2x plus 3y plus 4z, does not represent the total number of components. The 6x plus 9y plus 12z does. So, quite often in these questions they use 40% of the total, and it's a useful fact to know that 40% is the same as 2/5. So 2/5 of the total components is 6x plus 9y plus 12z. And we need to compare that with the total number of components of type A, which we have written down here, 2x plus 4y plus 3z. And people often get the inequality sign the wrong way round in these parts of the question. What you need to do to get it the right way round is think about which should be bigger, 40% of the total or the number of components of type A. And it says at least 40% must be type A. So this side of the inequality must be bigger than 40% of the total. So the inequality sign goes like that. Finally, we just need to simplify everything. So to get rid of this 2/5, I'm going to multiply it by 5 onto this side. That's going to give me 10x plus 20y plus 15z. And on the left, I'm going to multiply everything by 2 to get 12x plus 18y plus 24z. Now all that's left to do is collect like terms together. So I'm going to bring the x's over to this side to keep them positive. That's going to give me 2x on this side. I'm also going to bring the z's over to this side. That's going to give me plus 9z. And I'm going to subtract the 18y from both sides to get that that's less than or equal to 2y. So my 5 inequalities are 1, 2, 3, 4, 5.